Assalamualaikum to all the panels. I would like to introduce myself. My name is Nur Zafira binti Muhammad Hanafi from 4BEK GS3. Today I would like to present my final year project 2 and I will provide slides and simulation for the details.
I will start with my PowerPoint slide. So my topic for final year project is compression algorithm for smart distribution system. My supervisor is Miss Arfa binti Ahmad. Let's start with the introduction. So smart grid is the power grid that had been upgraded. Smart grid use two-way digital communication. So the primary technology in the smart grid is AMI, which is Advanced Meter Infrastructure. AMI will enable the process of collection and distribution between the utilities and meters. AMI consists of several elements which are advanced sensor, smart meters, monitoring system and also data management systems. Let's move to the motivation. AMI generates a big volume of data every day. The limitation in the communication network prevents all the data to be delivered to the control center. Hence, this project is being motivated to introduce the data compression method. The problem happens when limited bandwidth cannot accommodate a large amount of data from AMI to be delivered to the control center. Hence, data compression will solve this problem. There are two objectives in this project, which is first to compress the smart grid data via SVD, which is singular value decomposition. Second objective is to analyze the performance of SVD in compressing large size of data. Several scopes in this project. First, I focus to the data compression by using SVD method. Second, the experimental test using MATLAB and no hardware involved. And then the data that been used is from Customer Load Active Service project in England. I will explain about the literature review in this project. So compression can be defined as a technology that can reduce the size of the file from the original size, making it easy to manage. So there are two concepts of data compression, which is lossless and lossy. So lossless is the file after being uncompressed, the size will be same as the original size. Meanwhile, for lossy, the size will be reduced after being uncompressed. For the compression algorithms technique, there are two types, which are coding-based method and also mathematical-based method. So there are three criteria in order to evaluate the compression algorithms technique. First, calculating data compression ratio. Second, by calculating the compression speed. And third, by observing the data compression complexity. Next, for the singular value decomposition method, so SVD is defined as the metric decomposition that can be applied as a compression technique. So SVD is actually a lossy method. So it has been widely used in compressing video, image and audio. I will proceed to the methodology. So this is the flowchart for my project. I will explain each of the process. For the first process, which is dataset, actually the dataset that have been used in this project is from the Electricity Northwest company that owns the electric power distribution in the northwest of England. So the dataset is actually been downloaded in the internet from the project name Customer Load Active System Service class. So the data is from the 50 substations in the different places in England. So the data consists of several parameters, which are voltage, current, active power and reactive power, and they are being collected for every 1 second in a day. Second process is data pre-processing. Before SVD compression method can be done, data pre-processing must be settled first. So if there are any missing values in the data, the missing values must be replaced by taking the average from 3 previous values. And then, the data from the 50 substations have to be merged according to the variables such as voltage, current, active power and reactive power as in table 1. This is table 1. The size of the data will be according to the types of variables. So there are 5 types of variable, which is voltage, current, active power, reactive power and combination of them. All the variables have different size of data. So 3600 refers to the time for the data being recorded, which 1 hour produce 3600 seconds. And for the right side is the total parameters recorded. I will give some illustration for process 1 and process 2. So this is the data set which have been downloaded from the class project. So it involves 50 substations, and each of them have 3600 seconds and 16 parameters. So it involves voltage, current, active power and reactive power. For the second process, data preprocessing, for example, if this value is 0, which is missing value, so this value must be replaced by taking the average from 3 previous value, and then this data must be merged according to the variables. For example, this is voltage data that have been merged from the 50 substation just now. So the size of data will be changed, which is 3600 seconds, and the meters will be 300. For the third process is SVD compression algorithm. I will explain in terms of mathematical concept. Firstly, the measurement from meters is taken over time instant, which need for every dataset in order to specify the size of the data. Next, the data is said to be put in the form of metric X and can be illustrated by this figure. As we can see, time instant must be at the row and meters must be at the column. Next, XVD compression starts with this formula. The matrix decomposition produces matrix U, summation, and also V. V must be transposed. Then, after computer equation 1 in the MATLAB, we notice that U and V are orthogonal matrix, while summation is a diagonal matrix that contains singular values element. Then, equation 2 shows the detailed SVD formula to explain the size of every matrices. Next, assume R as singular value that have to be written in summation. So let matrix XR be new matrix of X after computed the SVD expression just now, and replace summation to new summation. So formula 3 is formula for new matrix of XR. Then each matrix just now from the product of XR will be partitioned into all these submatrices. So all this formula must be evaluated in the MATLAB in order to calculate the new matrix of XR. After performing the multiplication at 3 just now, so this is the resulting of XR in equation 8. So we can see that only 5 submatrices that is needed, which are U11, summation 11, B11, U21, and B12. So there are several submatrices that have been lost. So that's why SVD is a lost method. So as a result, XR is the end of data that have been compressed. In order to calculate the value of singular, which is R, compression ratio must be set first. So R can be calculated manually by using this formula. Next, for the fourth process is performance measurement by using MAE and MPE. So this formula MAE and MPE will be computed in the MATLAB in order to evaluate the error for the compression process. I will proceed to the results and discussion. In this part, I will explain thoroughly with the simulation provided. As illustration, I will use voltage data with the size of 3600 times 300. So the TCR that have been set is 2:1. The calculated R must be rounded to the nearest value, which is 138. So I will show the coding in the MATLAB. The coding starts with the calling information for the voltage data in the Excel Microsoft. And then, as the voltage data have the T is in columns and the M is in the rows, so it has to be transposed according to the SVD method. Next process, which is the SVD formula. So this formula that will decompose the matrices U, summation matrix, and also V in the MATLAB can be shown in this formula. Next, in order to evaluate the new matrix of XR, all this formula must be calculated first by inserting the value of M, T, and R. As we know in the previous method, only 5 submatrices will be calculated in order to form matrix XR. So the 5 submatrices will be shown in the MATLAB, which is S11, U11, U21, V11, and V12. For the next process is the new matrix of XR. This formula must be shown in the coding by this part. The singular value or R that have to be written in SVD method must be shown in this coding. So I have explained the coding process in MATLAB. Next, I will explain the output that have been computed in the command window. So after the coding have been run, so this is the output result. It will be computed based on this part. The voltage data that have been decompressed and the XR, which is the voltage data that have been compressed, will be shown only 1 to ratio 10 because the size is too bigger. So I just put 1 to 10 in order to show the difference between the decompressed and compressed data. Since only these 5 submatrices are needed in SVD method, the compression process has been proven when there are some of the data in the submatrices U and V had been lost. For the evaluation, to evaluate the error of the SVD compression, we can see by using MAE and MPE. So when R equal to 138, MAE is 0.3217 and MPE is equal to 0.0531. The coding process will be repeated with different set of TCR. So this is the example result for voltage data. As we can see, as the TCR decreases, the value of R will increase. Hence, the MAE and MPE will decrease. The MATLAB process also will be repeated for other variables such as current, active power, reactive power, and combined data. So as we can see, the overall MAE for all the variables, it shows the declination graph. So it means the error will be decreased with higher R. So loss of the information will be reduced. Hence, the compressed data will achieve highest accuracy compared to the original data. So, lot of data can be sent to the control center. As there are a lot of data that will be sent, hence it uses high bandwidth to send all the data. So, the bandwidth saving will be decreased. So, we can conclude that SVD compression performance for MAE lies on the TCR that have been set. This is the MPE result for all the variables. As we can see, they show the declination graph. However, for the reactive power, there are some fluctuation happen from 2 to 7. So it can be concluded that the best performance will achieve when R is at the highest. As a conclusion, the lower TCR value will produce higher value of R. The best performance of SVD compression will be achieved with the highest value of R. However, the availability of communication bandwidth must be checked first before setting the TCR value. As we can see, in this project, the objective had been achieved, which first, compressing the data via SVD, second, analyzing the performance of SVD compression. For recommendation, when conducting this project, there is a lack of computational efficiency in the MATLAB when compressing the large size of data. Hence, it is been recommended to use other version of SVD method such as KSVD or other compression method. So that's all from me. Thank you.